So in Module 2, we're going to start looking at systems of equations. And in Section 1, we're specifically looking at solving systems of equations by graphing. So we're going to start off with what is a system of equations. So it's a set of at least two equations that contain at least two variables. We are going to start looking at a set of equations with two equations and two variables. But there will be a section where we look at three variables and three equations. So it's exactly two equations or exactly two variables. You can have three equations and three variables, or 4 and 4, or 3 and 2. Like, there's no limit to how many equations you can have in a system and how many variables you have. So a solution to a system of equations is a point that satisfies both equations. And we're not always going to write our solution as a point, but typically when we talk about a point, we do mean x comma y. Okay? Like I said, there will be a point when we talk about three equations, which would be x, y, z, but for right now, we're talking a point x, y. So we want to determine if we have a set of ordered pairs, which is what we call a point, which of them are solutions to our system of equations. So remember, it has to satisfy both equations. So the first point I'm going to check is the point 2, 3. So I'm going to check that 2 plus 3 equals 1, and I have to check that 2 times 2 minus 3 equals 11. Well, I can tell you right now, 2 plus 3 is 5, which does not equal 1. My second equation becomes 8 minus 3 equals 11, which is also 5, but still doesn't equal 11. So the point 2, 3 does not work. Okay. Next, we're going to move on to our point 4, negative 3. So we're going to do 4 plus negative 3 equals 1. And we're going to do 2 times 4 minus negative 3 equals 11. So 4 plus negative 3 becomes 4 minus 3, which is 1. So 1 equals 1. My second equation becomes 8 minus negative 3, which becomes 8 plus 3, which is 11. So 4 negative 3 works. Okay. My last point is 1, 1. So we're going to check that 1 plus 1 equals 1, and 2 times 1 minus 1 equals 11. Well, 1 plus 1 is 2, and 2 does not equal 1. And then 2 times 1 is 2. So 2 minus 1 is 1, which does not equal 11. So that one doesn't work. So the only ordered pair that is a solution is the point 4, negative 3, because it is, you get a true statement for both equations. Now, it's very difficult to just check points until they both work, which is why we have a graphical solution. So the way that works is you graph both equations and find the point where they intersect. So if you're looking at a graph of two equations, the solution is the solution where they intersect, because if they intersect at that point, that's when they're both the same. So we are going to be graphing equations by hand, and anytime I ask you to do this, I will provide you a little 10 by 10 graph to use. All right, so our first example, we have the equation x minus 2y equals 0 and x plus y equals 6. Now, we do want to make sure when we're graphing our equations, we're using mx plus b form. So sometimes we may have to reorder the equations. So I know if I have to subtract x from both sides. So I get negative 2y equals negative x. I'm going to divide by negative 2, and it becomes y equals 1/2 x. My second equation, to get in that form, I just subtract x, and we get y equals negative x plus 6. So now I'm going to graph. So the y equals 1/2 x has a y-intercept of 0, so I'm going to start at 0. And then a slope of 1/2 means go up 1 over 2. So up 1, right 2. Okay. It also means I can go down 1, left 2, and I'm also applying the same slope. Then all I have to do is connect the dots, and I get my line. Okay. Now we're going to do the same thing for y equals negative x plus 6. So my y-intercept is a positive 6. And then a slope of negative x is down 1, right 1. I can also go up 1, left 1. Connect my points, and I have my system of equations. So the point where they intersect is right there, which is going to be at 4, 2. So remember, we always write x and then y. So if you don't remember, the x-axis is the one that goes left to right, and the y-axis goes up and down. My second system, y equals negative 1/4 x, 1/2 x minus 4, and x plus 2y equals negative 10. So my first equation, already in y equals mx plus b, so I don't have to do anything with it. I just have to reorder my second equation. So I'm going to subtract x. We get 2y equals negative x minus 10. Then we're going to divide everything by 2, and we get y equals negative 1/2 x minus 5. My first equation, I'm going to graph and start with my y-intercept negative 4, apply a slope of negative 1/2, down 1, right 2. Okay, also apply the slope of up 1, left 2. Then connect my points. Okay. My second line, I have a slope of a y-intercept of negative 5. I'm going to apply my slope of also negative 1/2, down 1, right 2. And then up 1, left 2. Now if I look, these lines don't touch. There's no intersection. So when the lines don't intersect, okay, that means there is no solution. Okay? There is no point that I plug in for x and y where the equations are going to equal each other. Okay, next we have x minus y equals 5 and x plus 2y equals negative 4. So my first equation to isolate, I'm going to subtract x. We get negative y equals negative x plus 5. Then we're going to divide everything by negative 1. So we get y equals x minus 5. My second equation, we're going to subtract x from both sides. We get 2y equals negative x minus 4. Then I'm going to divide everything by 2, and we get y equals -1/2 x minus 2. So at this point, I want you to go ahead and pause the video, graph both of the lines, and see if you get the same solution that I do. Okay. So if I start at -5 and I apply my slope of +1, your line should look like this. And then my -1/2 minus 2 you should get a line like this. So when I look for my solution is where they intersect, which is at 2, -3. All right. Next system, 9x minus 6y equals -6, and 6x minus 4y equals -6. So go ahead, pause the video, and get it in y equals mx plus b form, and then I want you to check and see if you end up with the exact system that I do. I'm just going to walk through the steps on this example and not show the work. So I'm going to do a minus 9x from both sides, and then I'm going to divide by -6. So I should get 3/2x plus 1. Okay. My second equation, you minus 6x. We're going to get y equals 3/2x plus 3/2. So when I go to graph, my first equation, y equals 3/2 x plus 1. Y-intercept of 1, slope of +3/2, which I can also do the -3/2. Okay. Now my second equation, my y-intercept is 1.5, which is not so much of a nice number. And it's going to be very hard to graph these because their y-intercepts are so close to each other. It's going to be very hard to graph so that they line up. So they're going to be pretty much touching. So I know this isn't a very accurate representation, but their y-intercepts are so close to each other that it's going to be very difficult for me to graph this. But another key thing you can notice is if you're looking at a system of equations with the same slope, okay, that means they're never going to intersect. So that should be an immediate red flag to you that there is no solution. All right, and if you look at our previous example that had no solution, you'll also see they had the exact same slope. So both of these have a slope of 3/2 x. So it doesn't matter what their y-intercept is, they're never going to touch because they're going up, or their slope is increasing or decreasing at the exact same rate. All right, last example, we have 15x minus 6y equals 0. And 5x minus 2y equals 10. So if I get it in slope-intercept form, by subtracting 15x and then dividing by -6, I'm going to get -5/6x. And 0 divided by -6 is still 0, so I'm not going to bother putting the plus 0 there. For my second equation, I'm going to subtract 5x and then divide by -2, so I'm going to get 5/2 x. I divided wrong on that first equation. Forgot to simplify 5/3 x. That's my bad. Nope, 5/2 x. Man, I'm having a difficult time with this. -5/2 x. And then this becomes -5. Okay. So my first equation has a y-intercept of 0, and I'm going to go down 5 and then right 2. And then up 5, left 2. Connect my points. Okay. The second equation has a y-intercept of -5, and I'm going to go up 5, right 2. And then down 5, left 2. Connect those points. So these do intersect at the point 1, -2. Let me know if you have any questions over solving a system of equations by graphing.